Notice the title of this lesson is Solving Rational Equations and Inequalities. Back in Algebra 2, you worked rational functions a lot. Now, let's remember what in the world rational expression is. A rational expression just means there's an x in the denominator. That's all it means. There's a variable in the denominator. Now, you guys did in Algebra 2, you learned about holes and you learned about vertical asymptotes. And you learned about horizontal asymptotes, right? You don't remember what you learned in Algebra 2. You remember learning it, just don't remember how to do it. Okay, I'll take that. I'll take that. Okay. All right, I'll take that. Now, so what the first part of this is going to do is just going to kind of review you on some basic stuff with rational functions. And then we're going to get into some stuff with them that you haven't done yet that's really pretty cool. We really just have 2 lessons out of this unit that I thought were important for us to focus on for you for future use, future reference. All right, here we go. The graph of the rational function, this bad boy g, is pictured to the right. You see it here. Now, what do you see in this picture that might be kind of interesting? You see a hole. You see a vertical asymptote, and you see a horizontal asymptote. Now, and that's all that's interesting. Okay. Do you remember from Algebra 2 how to find a horizontal asymptote? That's vertical asymptote. Here's what you think. Now, here's what you think in Algebra 2 and Pre-Cal on how to find a horizontal asymptote. What's the degree of the numerator? 2. What's the degree of the denominator? 2. If the degrees are the same, then you take their coefficients. So that's a 1 and that's a 1. So you take the coefficients of the term with the highest degree, okay, if they're the same degree. So it's 1 over 1, which is 1, so y equals 1 is your horizontal asymptote. Now, in calculus, you will learn the mathematics behind why that is true. Okay. Now, we're going to get to this chart here in just a little bit. Well, we can do number 1, then we're going to have to wait on the others. Look at number 1. It says g of x equals 0. What does that mean when you look at this graph? What's it mean? When y is 0. How can you look at a graph and say, oh, that's where y is 0? The x what? Intercepts. The x-intercepts. Because on the x-axis, what is the y value? 0. All right. So does this graph have any x-intercepts? Where? So your answer here is, yeah, g of x equals 0 when x is negative 1. Now, let's go down here. You're like, you're not going to do the rest of it? Yeah, we will. Okay, given that function, find the function values of g of negative 3 and g of 1. Now, here's what we're going to do. We're going to do it this way. G of negative 3. Let's do that in your head. Negative 3 squared plus negative 12 plus 3, 0. Negative 3 squared plus negative 6 minus 3. 9 plus negative 6 is 3. 3 minus 3 is 0. What's that? It is definitely undefined. Why is it a hole and not a vertical asymptote? When you get 0 over 0, in calculus, we call that you don't need to know the word right now. Can you pronounce it? Indeterminate form. Yeah. Indeterminate form. An indeterminate form means, hey, there's something else I need to do. Direct substitution doesn't work. So we're going to come back and talk about that in a minute. Did you write down g of negative 3 equals 0 over 0? Okay. Because I don't want you to lose that. Now let's talk about g of 1. Substitute 1 squared plus 4 times 1 minus 3 plus 3 over 1 squared plus 2 times 1 minus 3. What's that? That's undefined as well. That's a different kind of undefined than 0 over 0. What do you have at x equals 1? Aha. Now, here's the deal. When you get 0 over 0, your graph will have a hole. When you have a non-zero divided by 0, your graph will have a vertical asymptote. Now I want us to put a different spin on that one. Let's factor it. Numerator and denominator. Factor those suckers. Well, that numerator factor. Go. Okay, you can factor faster than that. How do you factor that numerator? Over. What do you notice? Yep. The x plus 3's factor out. And you're left with x plus 1 over x minus 1. Now, ladies and gentlemen, if you graphed on your calculator x plus 1 over x minus 1, it would look exactly like this, except there would be no hole. Because what we did when we factored out the x plus 3, we factored out the hole. So if you graphed x plus 1 over x minus 1, there would just be no hole. Okay? And then what you are left with, that x equal 1 gives you the vertical asymptote. Make sense? Now, we've already talked about this, so we're moving on. Now you should be able to answer the questions that go in these two boxes real quick. For that function, what x values make that function equal to 0? We already answered that, didn't we? Because, ladies and gentlemen, I want you to look right here. A fraction is equal to 0 when what part of it is equal to 0? The numerator, and x equal negative 1 makes that numerator 0. What value or values of x makes this function undefined? And now you better notice the 1, come on, there we go. The 1 comes from right here, but the negative 3 came from right here. So that was your hole. Questions so far? Now let's go up and answer the rest of that table. Number 2, g of x is greater than 0. What's another name for g of x? How can you look at that graph and decide when is y bigger than 0? When it's above the x-axis. Good. Where do you see this graph being above the x-axis? From negative infinity to where? Wrong. Stops right there, doesn't it? That graph's undefined right there. So negative infinity to negative 3. Now, is negative 3 included? No. Where else? Negative 3 to negative 1. Good. Is negative 1 included? Why? Because at negative 1, x is equal, or y is equal to 0, not greater than. We got any more? Or is that it? Yeah. All of this is above the x-axis. So what's that from where to where? Is 1 included? Nope, because what's there? Vertical asymptote. Good. So far, so good? Next question. I got to erase this because it gets in my stuff. It gets in my space. G of x is less than 0. Graphically, where does that happen? Is negative 1 included? So negative 1 to 1. Is 1 included? No. Look at the next question. Where is g of x greater than or equal to 0? Oh, so you're telling me that it's just like number 2, except what, Maria? Where? The bracket on negative 1, because negative 1 is included this time. Good. So we're going to have negative infinity to negative 3. Negative 3 is still not included. Negative 3 to negative 1, but negative 1 is included now. So what do you think the answer to number 4 is? 5. Number 5. Good. It's the same as number 3, except you have a bracket around negative 1. Good. This right here, let me just throw out some names here. That right there is called an open interval because it's open on both ends. Open means parentheses. If it had brackets on both ends, it would be called a closed interval. This, and don't ask me why, that's called a half open interval. Why isn't it called a half closed interval? I don't know. Somebody just decided to call it half open. So, yeah. No. I mean, not for test purposes. I will say them, so I want you to know what they mean. An open interval just means parentheses on both ends. Closed interval means both ends are brackets, so both ends are included. Now the question is, how could I answer these questions without having the graph? Can I answer these questions by just knowing the function? The answer is yes, or we wouldn't be doing this lesson. Okay. Can we fill out this without seeing this? Not, yeah, but we can start on the next page. Okay, so. You have done this a little bit, so it won't be completely new to you. To solve rational inequalities, what the crap is an inequality? Well, it could be, but it's also got what in it? It's got less than's and greater than's in it, or greater than's. All right, to solve rational inequalities. Now we're going to read this, you just may not understand it. The process is to follow, if I can talk, you might understand it. The process to follow is identical to the process previously learned to solve polynomial inequalities. We have done this before. except in the case of rational inequalities, we must not only divide the number line for sign analysis using values that make the function equal to 0, but also using values that make the function undefined. Now, that may sound like the Charlie Brown teacher. Wah, 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 wah. I promise it's easy. All right. So how do we solve this inequality right here? We want to know when that function is less than or equal to 0. Well, you say, well, I can look on the front page because we already did this. Yeah, but we did it with the graph there. All right, so here's what we're going to do. We're going to factor that sucker completely. Now, you've already done that. So let's just write it down again. If I factor right, we'll be all right. Now, let's look at number 2. Set each factor. Now, how many factors do you see? I see 4. I see 2 in the top, and I see 2 in the bottom. Now, one of them happens to be a duplicate. Set each of those factors equal to 0 to find the zeros of the function and the values where the function is undefined. My zeros come from what part of the function? Right, the numerator. And my undefined comes from the denominator. So, what x values would I have? What x value makes this 0? Done. Now we're right here. Draw a number line that is divided into segments using those numbers. Yeah, I know. Didn't we do this? We did with just a polynomial, not with a rational function. But yes, we did. Now listen, when you do this, please put them in the right order. Don't put 1, -3, -1. Okay? Put them in the right order. But it's screwed up. It ain't right. Well, now and then we are all screwed up, aren't we? Speak for yourself. All right, Jael. All right. Choose a number from each interval. Let's pick a number that's less than -3. Pick a number between -3 and -1. Pick a number between -1 and 1. Thank you for picking 0 and 2. Fine. Now let's look at what we're going to do with it. Determine the sign of each factor of the rational function based on the chosen value. So here's what we're going to do. If x is -3, fiddle. If x is -5, is this factor positive or negative? If x is -5, is this factor positive or negative? So the top is a negative times a negative. Over. If x is -5, this factor is negative times this factor is negative. So a negative times a negative divided by a negative times a negative is a positive. So what does that tell us? From -infinity all the way up to -3, whatever value you pick there, this rational expression is going to be positive. Which means if you graph it, where's it going to be? Above the x-axis. Good. Okay. X equal -2. I want positive or negative. If x is -2. Positive. Negative. Positive. Negative. So I've got a positive times a negative divided by a positive times a negative. What do I get? I get a negative divided by a negative, which is positive. Zero. Positive, positive. So the numerator is positive times positive. Denominator, positive times negative. All right. That gives you a positive divided by a negative, which is a negative. One more. If x is 2, positive times positive over now, my next question to you is, do those three numbers, -3, -1, and 1, are all of those numbers allowed? So do any of those numbers make the denominator 0? Because if they do, I can't use them because they make the fraction undefined. So I can't use -3, right? And I can't use 1. So what I'm going to do right here is I'm going to go right here and I'm going to do this now. And I'm going to say, self, that reminds me, I cannot have those numbers as part of an answer because they make the fraction undefined. Now, ladies and gentlemen, now I can answer all of those questions on the front. But let's do this. Look at number 4. Refer to the original inequality sign. The original inequality sign was less than or equal. You look here. Where is that rational expression less than 0? Between -1 and 1. Now, it said less than or equal. Do either one of the endpoints also make it true? -1 does. Does 1? No. There's your answer. That is exactly what we got on the less than or, oh, well, you have it. Do you have that right here? -1 to 1, half open. Okay. Now the last thing we're going to do is we're going to compare this sign chart that we did with the graph. From -infinity to -3, you said the graph has to be positive, meaning above the x-axis. From -infinity to -3, is this graph above the x-axis? Yep. We said -3 doesn't work. We marked it out. Does that justify with the graph? Because what's at -3? A daggum hole. And then we said between -3 and -1, we're still above the x-axis. Yep. At at -1, what are we? We are 0. That makes sense. We're good there. Between -1 and 1, we are below the x-axis. Does that make sense? Yep. Is 1 included? No, because what have I got there? Vertical asymptote. Good. And then bigger than 1 has to be above the x-axis, and that is. And that's a good place to end. Have a good weekend.